Hello again. Let us have one example for variance of random variable. Consider a uniformly distributed random variable in the interval of a and b. So this random variable between a and b, we have uniformly distributed. So the PDF, this is x. So the PDF f x of x is equal to 1 divided by b minus a if x is between a and b and 0 otherwise. And we want to calculate mean and variance of these random variable. Mean of x is easy. So sometimes we denote mean of x, for abbreviation we denote it by mu x, and mu x is equal to integral of f x of x dx from minus infinity to plus infinity. Obviously this integral, because the PDF is equal to this value if x is in this interval, otherwise is 0. So if x is not in the interval a and b, this guy is 0. Okay, so I don't need to write this. So I only write it from interval a to b, and in this interval my PDF is equal to 1 divided by b minus a, and then I have x times that, and then I have dx. So this is the integral I get. So this is the same as this one. So let me clean up things. And then if you do this integral of x dx is equal to d of x to the power of 2 divided by 2. And then if you put integral a to b, so this is going to be, you have to put it b, and then a, you say d of b to the power of 2 divided by 2. Minus a to the power of 2 divided by 2. Obviously you have divided by b minus a, and then you have 1 over b minus a. So you have to say multiplied by 1 minus b minus a. And if you simplify that, you could get this one. So we see that the center of the distribution here, distribution is from a to b, and then you have flat here and 0. The center of the distribution is a plus b divided by 2, which is exactly in the middle of a and b. So the center of distribution is expected value and is also the mean. So this is the midpoint of the interval. The variance of x, sigma 2x, is I have to calculate x minus its mean, which is x minus b plus a divided by 2, and then square these and then calculate expected value of this one. Okay, so it's gonna be like integral over all possible values from minus infinity to plus infinity of the value that this guy can take, which is small. This is the real value that it can take. It's not the random variable. Plus, minus b plus a divided by 2 to the power of 2 times PDF, which is 1 over b minus a dx. But this PDF is 0 out of the interval a and b. So instead of minus infinity to plus infinity, I need from a to b. Okay, so now you use your calculus, you go step by step, and then you calculate this integral. So if you calculate and simplify it, you get b minus a divided by divided to the power of 2 divided by 12. So what we got here is that the distribution was here a, b, and expected value was a plus b divided by 2. But this guy is this length, which is b minus a, the square of these to the power of 2 divided by 12. Or you could say that the standard deviation, sigma x, is a square root of b minus a to the power of 2 divided by 12, which is equal to 1 over square root of 12 times b minus a, absolute value. So the length of this distribution times this constant gives you the standard deviation. So length to the power of 2 divided by 12 gives you the standard deviation. This is generally seems to be true for most of the distributions. So the standard deviation is defined as this for these uniformly distributed random variable. Uniform random variables are used in many engineering applications to model the lack of knowledge or complete indifference over an interval. And some people, they consider it as a principle of insufficient reason. When they don't have anything to say, they say, assume that it's uniform distribution.